Good morning. Thank you again for being here. Before I get started, just like to thank the crews of the USGS large vessels Sturgeon and Arcticus, as well as the Fish and Wildlife Service research vessel Spencer Baird for their assistance in completing our prey fish monitoring survey efforts each year. We very much appreciate the dedication and professionalism of these individuals. Also like to thank our Ann Arbor-based USGS tech staff for doing some great heavy lifting for me to assemble the data for this talk. So as Paul mentioned, our goal this morning is to assess progress towards the fishery community objective for the offshore prey fish community, which is to maintain a diversity of prey species at population levels matched to primary production and predator demand. Essentially, the two questions or objectives we want to get at this morning, we want to look at the degree or extent to which the current offshore fish community is meeting this objective, and try to provide some insight into how things have changed since the last reporting period, which covered the years 2011 to 2017. To do that, we're mostly going to leverage data from the USGS prey fish surveys. Purpose of these surveys is to describe trends in species composition, relative abundance, and age and size composition of offshore prey fish communities. So we're specifically looking at working in areas with bottom depth greater than 9 meters. We do this in using two different gears. We have a bottom trawl survey, which obviously targets species and age classes that are more closely associated with the bottom. This is our longest running survey. We're rapidly closing in on 50 years of data, which is fantastic, incredible. But we also have I should back up and say, but this survey only covers the main basin. We also have a acoustics midwater trawl survey, which targets pelagic prey fish species and life stages. Unlike the bottom trawl, it surveys all three major basins of the lake, but it was only started in 2004. For simplicity this morning, I'm going to focus mainly on trends in the main basin where both surveys cover. If you want more information on prey fish dynamics in Georgian Bay and North Channel, I'll direct you to our draft report, copies of which are out on the main table. The fish community objective for prey fish here doesn't really lay out, it lays out some kind of general characteristics of the desired prey fish community, but doesn't really identify specific indicators or targets. So I developed some, hopefully that hopefully captures some of the essence or core of what's being driven at in this objective, but I'm sure we could have a long and fruitful discussion on whether these are quote unquote the right way to go about this. But anyway, the prey fish community objective does make it clear that one, diversity is an important part of what we're driving at. And although it's not specifically mentioned in here, the species diversity FCO also makes it clear that the folks who put this together were also interested in the status of indigenous species as well. So the first two indicators I'm going to look at is just using a simple Shannon diversity index calculated for each year of our surveys. The second is something I call an index of native species importance, which is simply the percentage or proportion of prey fish biomass composed of native species. So we'll use those two indicators. And then as for targets, we'll use a target of 75% of the time series maximum for the Shannon diversity indicator, and we'll use a level of 75% of biomass composed of native species as a target for the native species indicator. I'm sure you could quibble over those particular targets, but both of these indicators and targets have been used for several years now as a way to assess prey fish community health in prior EPA State of the Great Lakes reports. So at least they have a little bit of precedents going with them. The second part of this objective is much harder to get a handle on, determining critical levels of prey biomass or abundance that specifically meet, that are perfectly matched to the available nutrients entering the system, and predator demand oftentimes requires fairly extensive modeling that even afterwards you may not be happy with the precision of the results. So we're going to take a bit more of a qualitative approach here. I pulled in some data from the EPA's lake-wide monitoring program on nutrients and chlorophyll, and we'll take a look at how well those two metrics predict prey fish biomass, and we'll look at different years in the current period to see how well current biomass matches what you might predict from those relationships to the extent that we can make them. And then for determining whether prey fish are meeting the demands of predator, we're just going to look at a long-term time series of predator conditions, specifically lake trout, that He from the DNR Alpena station provided with me. So to jump into some results, we'll first look at these diversity metrics. So this is the time series of Shannon diversity for the demersal fish from the bottom trawl time series. You can see it varies a lot. I fit like a really simple trend line to this data. You can see that it starts out at intermediate levels, rises to a peak, drops off a cliff, and then since about the early 2000s has been kind of tracking back upwards. But over the last decade plus, there's been just a ton of variability in that metric. All diversity metrics are functions of the number of species in the community. So for the species in the bottom trawl survey has remained fairly constant over time. The median is about 12 different species sampled in that survey. So that changes in the number of species in the community really isn't explaining any of these trends. But the other part of a diversity metric is something called evenness, which is simply the distribution of abundance across different prey species. So if you have really equal numbers of different species, you end up having a more diverse community. You can see that curve or that trend matches really closely to what the diversity index is doing, which means the changes we're seeing is related to relative differences in the relative abundance of different species. So let's take a look at that. Here's basically lake-wide biomass from the bottom trawl survey broken down into different species. You can see that this peak in the 90s of high diversity corresponds to a period where we have high abundance of rainbow smelt, alewife. It's a little harder to see on here, but sculpins were also relatively abundant, and also bloaters went through an initial period of population growth here, and because of that we have high biomass spread across 4 or 5 different species. We have higher diversity. Then things start to change really rapidly. We have Dreisseniids coming into the system. We lose Diparia. Abundance of some of these species starts to come down. Then we have probably the exclamation point on all that is the crash of adult alewife populations in 2003. And as all that happens, biomass comes screaming down and reaches all-time lows. And I can't see it from here, but I think it's in the 2014 to 2017 range. And since that point, we have very low biomass, but the other thing that's going on here is that most of the prey fish biomass is lumped into 1 or 2 species, which is why we have such low diversity measures here. And the species that often accounts for most of this biomass is bloater. So you see in recent years here, the percentage of prey fish biomass that's composed of bloater can reach 85, almost 90%. It's just incredible, with the remaining 8 or 10 species combining for only 10, 15, 20% of biomass. The diversity index is kind of a strange thing because even if we had a community with lots of exotics that were equally spread across, equally abundant, we would get a high diversity index, which is not necessarily what we're going for here. So I reran this stuff using, let me back up and say, we also see the same kind of trends in the pelagic species. That's the figure showing the diversity metrics for the pelagic fish from the Acoustics Midwater Trawl Survey. And that top graph is the species, the biomass by species breakdown. And again, you can see that most of the biomass is concentrated in bloater. So backing up again to where I was going was I redid this metric using only native species. And here you can see diversity drops off a cliff starting in the early 2000s. You again have issues with a lot of unevenness in the community, but here you actually are seeing some erosion of species. So we are seeing some declines in the number of native species we're observing in the bottom trawl. These are plots of frequency of occurrence of a few different species in the bottom trawl series. You can see that species like nine-spine stickleback, trout perch, and slimy sculpin are really occurring at frequencies in the survey at much lower than we've seen historically. That vertical hashed line there marks the point where we switched from a 39-foot to a 70-foot bottom trawl. That doesn't seem to impact the trends for most species. There is a little bit of a jump in the frequency of occurrence for slimy sculpin, but even after we switch to that net, you can still see a declining trend in the data. So let's take a quick peek at native species importance here. This figure shows the percentage of native species by biomass in the bottom trawl time series. You can see recently we're kind of hovering right around the target level. But I had an old professor telling me that proportions or percentages make bad statistics because they're easy to misinterpret, and I think this is a case. So if we look at the total biomass of non-native and native species in the bottom trawl, you can see that the increase in native species importance has less to do with increases in the actual abundance of native species and more to do with a rapid decline in biomass of non-native species, particularly alewife and rainbow smelt. Another reason to be a little bit cautious about being optimistic about that stat is that if you were here for Peter Esselman's talk on Monday, you know about this guy around Gobi, showed up in our bottom trawls for the first time in '97. Its abundance is highly variable in the bottom trawl series. When we see it, it's really abundant, but there's lots of years when it's kind of low. We know that this species is probably way undersampled relative to some of the other species in our time series. So our importance of native species index is probably a lot lower than we think, primarily because we almost certainly undersample round gobies in the bottom trawl. All right, let's take a quick peek at how prey fish abundance or biomass is related to some lower trophic level variables. This is a plot showing total biomass from the bottom trawl series as a function of spring total phosphorus measured each year by EPA in the main basin. I was surprised at this. There's actually this is log transform, there's still a fairly decent relationship here. And the thing I want to point out is that these blue and red dots, basically the blue dots correspond to years in the prior reporting period. The red dots are in the current reporting period. And there's some indication that prey fish biomass was well below what you would predict based on spring total phosphorus in the prior reporting period. But the 2 years that we have TP data in the current year, 2018, 2019, those predicted fish biomass fall relatively close to the curve. So That's at least some indication that the current community is not terribly far off from what might be supported by nutrient levels. However, when we try to pull in chlorophyll, this is spring, I think May is when they do this, chlorophyll data, the relationship is it's like P of 0.65, so it's kind of, a little wishy-washy relationship there. It only explains, chlorophyll A in the spring only explains about 18% of the variance in prey fish abundance, but there's still, a nominally significant trend there. Again, we see some of the years in the prior period, biomass was low relative to what we would have predicted based on spring chlorophyll. But again, most of the years in the current period are falling, pretty close to what we might expect from this admittedly loose relationship. Some of that might be because there's been a lot of change in the seasonal dynamics of chlorophyll and phytoplankton in the system. This is just a screen grab of a figure from a recent EPA report, which shows that we've really, this spring chlorophyll or phytoplankton bloom has really dropped off in recent years. So that may be one of the reasons why this relationship isn't quite as tight. Now switching over to looking at predator conditions. So as I said earlier, Jihe from Michigan DNR has been modeling condition of lake trout for several years now. My condition metric is the weight of a 700 millimeter lake trout that works out to about 27 or 28 inches. If we look at that over time, you can see that there's a large break in the trend right as alewife decline. Not terribly shocking, as the alewife were a really preferred prey of lake trout. However, that skid is sort of stabilized, and if you squint, there's maybe even a little bit of an uptick in condition in recent years. Part of that may be is that these fish seem to be able to use round goby without a problem. And so perhaps round goby could serve as an alternate prey resource for them. But again, you see after we reach into this low prey fish biomass period, that metric is just all over the place. There's a lot of variability again. So let's try to stitch some of this together. So in terms of species diversity in general, we're well below what the targets we set, especially for native demersal species. Our native species indicator is kind of close to that 75% mark, but chances are, given the undersampling of bloater, we're probably not as in good shape there as the numbers would indicate. And the relationships we develop between prey fish biomass and lower trophic levels and prey fish species composition and predator conditions suggest that we're in general, meeting the spirit of that FCO. A couple of other comments here is that there's a lot of variability in these community metrics in recent years, and that's something you would probably expect in a system with low diversity. We know ecologically that there's a relationship between system stability and diversity. Systems with low diversity tend to be much easier to move to new tipping points or new phases. We didn't get into this much, but there's low functional diversity in this prey fish community. We lack a true offshore epipelagic planktivore. Some of the species that are the dominant prey fish right now, bloater and rainbow smelt, are really generalists in their feeding. They'll eat microzooplankton, they'll eat benthic macroinvertebrates. Smelt will also eat small fish in addition to each other. So they're really adept at eating whatever's available. Stuff that's really specific to like diparia or zooplankton, we don't seem to have very much. On the upside, we have some species that are doing quite well, like bloater. It recruits well, it self-regulates. Age-wise, it's consistent of multiple age groups, so it's a good looking healthy population from a stock standpoint. And we also have the lowest abundance of non-native planktivores that we've seen in a long time. In terms of the changes we've seen between periods, we just haven't seen much change between the 2011, 2017 and current period. Most of the metrics are pretty similar. So what's the bottom line here? Well, it kind of depends on your goalpost. If you're the type of person that's going to look at the ancestral state of the system and say, how would our current prey fish community rank? I don't think you'd have any choice but to call it poor. We don't have many of the deep water ciscos that we used to have in this system. Many of our demersal species that were formerly an important part of the prey fish community and food for native predators are declining, and non-native species are still really common and relatively abundant in our system. If you want to say that some of that damage is just simply irreversible and that's not the true goalpost that we can use to rate the current community, then you can be a little more glasses half full. We have low relative biomass of non-native, some of the lowest we've ever seen of non-natives in the system. We also have current lake conditions that may be more conducive to recovery of some of the nearshore forms of cysto, et cetera. So in that regard, maybe you could make the argument for rating this community at a fair status, for example. So I'm over time. Thank you very much for your attention. I appreciate it.